So I'm trying to debug my Catgirl Synth analog logic. This is a circuit by Kinstone. I'm getting NAND and OR outputs, but not and OR outputs. So I think I traced at least part of the problem down to here and here. If I look at this layout of the older version of the board, I should have continuity between this 10K and 1K on this side. But I get a beep when I try to check continuity here, but not here. So that makes me think this solder joint may be suspicious. Oh, yep, there's a lifted pad. Should have noticed that earlier. Anyway, I've given this to various students over the years and other boards like this to various students over the years for soldering practice. So there's a variety of things going on. You want a janky, mediocre bodge connection? We got your janky, mediocre bodge connection. This is the earlier revision of the board. So if you look at the schematic, the outputs aren't set up like this. This confused me for a while. The outputs are actually set up like this with 1K in series with the output. Anyway, something strange is going on. Supposedly, if you put inputs into this side, then the lowest voltage shows up at the OR output. And if you put inputs in over here, then the highest voltage among those will show up at the AND output. And the only difference between the NOR and the OR and the NAND and the AND output is one is just an inversion of the other around 0 volts. But taking a look at the output here, well, I should first tell you what's going in. So the signal generator here from the scope is inputting 200 hertz, 5 volts peak to peak with an offset of 0, putting in a triangle wave, and over here I'm putting in a 200 hertz ramp wave. So that's a sawtooth. Again, it's 5 volts peak to peak centered around 0. So I would expect the output to be centered around 0, but it is distinctly not. It's centered, I don't know, it's down here at somewhere around minus 11 volts. Oh, and I should clarify, the yellow line is the NOR output, and the green line is the OR output. So the OR is definitely not the inversion around 0 of the NOR, and it's hard to see at this scale, but there is a signal here. It's a lot quieter than this signal here, but they're all stuck way down there. Oh, that's interesting. So the NAND output, that's centered around 0, the way I would expect, but the AND output is definitely not just the inversion of the AND output. So I just checked to make sure that the positive inputs of these op amps all have continuity with ground. But now check this out. If I look at the voltage at pin 6, which should be at a virtual ground associated with the NAND output, I see that indeed we get something close to ground. But now if I look at pin 2 here, which is associated with the AND output, if I measure the voltage at pin 2, I get minus 5. It is not being held at a virtual ground. Okay, what about the stuff over here? Let me check pin 6 associated with the NOR output. Look at that. That is minus 8. That is not a happy virtual ground. And let's see, if I look at pin 2 here, which is associated with the OR output, that's stuck at minus 10. That is not ground. I'm gonna measure the resistance between, say, pin 1 and 2 and pin 7 and 6, and pin 1 and 2 and 6 and 7 over here, and see if I read something close to 10K or something weirder. Maybe they're not getting the proper feedback. Okay, remember the outputs actually look like this, and when I measure between the output and the negative input pin on all of these, I measure 10K. So it looks like it should be getting proper feedback. Oh, are the op amps bad? Do I have to replace the op amps? Oh, I think I remember something. I think the students had just soldered these straight in. And I think there might have been an issue, if I remember correctly, where these op amps were bad and we had to replace them. But they were bad in a very bad way. Like they actually got hot. So wound up replacing those. So maybe whatever it was that messed up these op amps, maybe somebody reversed the voltage or something at an earlier testing phase. Maybe it also messed up these op amps. Actually, let me check the output of pin 8 here and pin 8 here before the buffers. There's one of the pin 8s, and that's nicely centered-ish around ground. And here's the other pin 8. So it looks like things are good up until those buffers. So it's time to swap out these dual op amps. Okay, I got the old op amps out. And yeah, I should have used sockets to begin with. Here's the NAND output. So we're now centered around ground, more or less. I can play different games and get that in a different spot. And here's the AND output, which looks like the inversion of what we just saw around ground. Yay! And here's the NOR output. It looks smaller. Oh wait, there's this span control. Let's see, I'll probably need to figure out how that's supposed to be calibrated. And here's the OR output. Okay, so it looks like we're cooking with gas. 200 hertz sine wave, 100 hertz sawtooth wave, and I'll adjust the frequency here. Okay, next I want to adjust these span Trimpots. So now I'm just using a single input and looking at the output to figure out how to adjust this Trimpot. The green is the input and the yellow is the output, and I suppose I should get those to match up. Yeah, that looks good. That was the OR channel. Now we'll do the AND channel, which is up here. Okay, let's adjust that Trimpot. That looks good.